Okay, so hi everyone. So welcome to today's course, and I hope everyone have a good vacation for the last 3 days. And I had one good vacation, and I don't want the vacation to end, Yeah. So most of the time, actually, the teachers don't want the vacation to end more than the students, because we need to teach, so we need to prepare more. But anyway, we still need to continue our learning. So today, we're gonna start a new topic. So before this topic, what we have learned? We have learned first C fundamentals. We learned about the basic format of C. You already worked on some simple program by yourself. We also talked about how to use printf and scanf. And last week, we talked about formatted I/O, formatted input and output. We talk more details about the conversion specifications. So I hope you guys still remember what is the meaning of conversion specification. And in other words, is that the conversion specification is a %D, %F you see inside the printf and scanf, but we can actually modify. We can actually have more different version of %D and %F and %E. You can add the minimum field width. You can also add P to represent the precisions. And you also learn the meaning of P will be different depends on which specifier you use. Depends on whether you use the %D or %F. We also talk more things about the behavior of scanf. So scanf is, I would say, is a powerful function, but also sometimes it can be very complicated, and it will be hard to understand why your scanf behave in certain ways. So I think it will be good if you can understand the basic behavior of scanf, and you can understand how the scanf scans input from us. So that is all the things we learned in the previous course. And today, we are officially going to introduce more different operators and expression. And I hope after learning today's course, you have the ability to write a more complex expression in your C code. And you will have the ability to use different operators. So again, this is the vocabulary we have for today. So in today's slides, you will encounter these vocabularies, and I will say some of them might be difficult for you guys. So I want you guys to understand the meaning of these vocabularies first. So we will talk about arithmetic, that is 算术. We will talk about logic, subtraction, multiplications, and divisions. And we'll also talk about something called undefined behaviors. And wait a minute. So, students, sit here. Please try to lower down your volume because you sit in the first row and your conversation really affects me. It is okay if you talk, but if you really need to discuss, please sit at the back seat. Okay? Thank you, guys. Okay. And then we'll talk about more different features about the operators. We'll talk about two things. The first thing is precedence. So we'll talk about the meaning of precedence here, but the semantic meaning of precedence is like this. We'll also talk about associativity. So this is the meaning of associativity. So by now you just need to remember the meaning of this word, but we'll talk more about what is the meaning of this word in your C code in a later slide. Okay, so this is the topics we're gonna cover today. First one, I will explain what is expression and operator. And then we'll talk about different kinds of operator. The first kind is arithmetic operator. So this is the meaning of arithmetic. Then we'll talk about another operator that is assignment operator. So we will do the assignment using the equal symbol, but there are actually more detail about assignment. So we'll talk about them in the assignment operator. Then the third kind of operator we'll talk about is increment and decrement operator. So the meaning of increment and decrement, is here, is that we increase a value and decrease a value. And then we finally will talk about expression evaluations. So in this topic, we'll talk about the order of how we evaluate different expression is actually important. So we need to know how the order of evaluations will influence the outcome of an expression. So yeah, that's all. So let's start with the first topic here, expression and operator. So in C, actually we often use a lot of different expression, right? Or you can see that this is the example here. We can use this expression to implement different arithmetic formula or different condition or different things we want our C code to do. So this is just one example to show you how we can convert this algebraic expression, this mathematics expression into C expression. So you can actually see that we can use C to implement a lot of difficult math formula. And the meaning, so when you see an expression in C, you will see that most of the expression have this following components here. So one expression can be built from variables, that is the variable we declare here, and the expression can be built from constants, that is the number we write in our code directly, and then we can add operator in the expression because we can use this operator to decide how we want to calculate the variables and constants. And we actually saw a lot of operators in the previous example. For example, we already showed you this code before, right? So in this code fragment, you can see we have expression here. In this expression, we have three variables, that is height, length, and width. And then we have different operator. We have one operator that is multiplications. And we also show you the expression that we use this operator, addition. And C has various types of operator. So this is the most common operator we will use. For example, arithmetic, assignment, relational operator, logical operators, and conditional operators. So there are a lot of different operators. And for today's course, we will introduce the first two, and we will introduce the other kind of operator in the later lessons. So first, let's check out what is arithmetic operators. So arithmetic operator can help us to do all these calculations. We can do additions, subtractions, multiplication, division, and remainder. So all these calculations can be fulfilled by the arithmetic operator provided by C. And this table just shows you the meaning of each arithmetic operator and some example. So let's check them out one by one. So the first set of the operator I want to show you is this 4. So this 4 is a basic calculation, right? I believe most of you know how to do this calculation, right? Otherwise, I don't know how you can get into this university, okay? Okay, so yeah, so these operators are pretty simple here. We can do addition, we can add I to J. And here, let's assume that I and J are two variables, are two integer or float variables. And we can also do the subtraction here. That is, we can in this case, we can subtract J from I. And we can do the multiplication, that is, multiply J with I. Again, we can also do the division. If we write the expression like this, that means that we want to divide I by j. So this is the first set of arithmetic operators I want to introduce. The next one I want to introduce is a bit different here, so that is why I want to separate this one from the previous set. So this operator is remainder operator. So remainder, if you check out the vocabulary here, oh, there's no remainder? Okay, here. So the meaning of remainder is here, so that is 余数. So we can also use this operator to calculate the remainder from this expression. So if we write down this expression, the meaning is that we want to calculate the remainder when 10 is divided by 3. So if we divide 10 by 3, the remainder will be 1, right? Because 3 multiplied 3 is 9, 10 minus 9 is 1. So that is how we can calculate remainder using this remainder operator. Finally, before I introduce the final one, we can check out that all these operators are, we will call them binary operator. So the reason we call them binary operator is that all these operators need to have two operand. So what is operand? So now you know the symbol, the plus symbol, minus symbol here, we call them operator, right? So the thing we put with an operator that we want the operator to calculate are called operand. So I and j here are operand. So in all these cases, I and j are all operand. And in this case, 10 and 3 are operand for this remainder operator. So you can see that all these operators need to have two operand, right? So that is why, because it wants 2. So the meaning of 2 is similar with the meaning of binary, right? So that is why we call it binary operator. It says that this kind of operator need to have two operand. So finally, let's check out the final set of operator. And this set of operator is unary plus and unary minus. So unlike the meaning of binary, the meaning of unary is that this operator only has one operand. So that is why it is unary, not binary, because the meaning of unary is similar with the meaning 1. So this operator, you can think about this is like the sign symbol we put in front of different values. So if we want to say that this is a negative value, we need to put a minus operator here. So for example, in this case, if we put a minus operator in front of j, then we can make j's value become negative. And for example, if we put plus in front of any value, we can make this value to become the positive value. So this is the effect of unary operator, these two operators. So the binary arithmetic operator, except remainder, allows either integer or floating point operand. We can also put both integer and floating point operands in the same expression using this arithmetic operator. For example, we can write the expression like this. However, if we mix integers and float operand in the same expressions, the return value of the entire expressions, or I can say the results of the entire calculation, will have the type float. So let's check out these two examples to understand the meaning here. So in the first example here, I add 2.5 to 9. So in this case, we mix two types of value in the same expression because 2.5 have the type floating point number, right? And for 9 have the type that is in integer value. So we mix these two value in the same expression. However, the result will be 11.5. So the return value of this mixing type expression will be float. So that is why even the 9 is the integer value, but the result here will be 11.9. And this is the same for the second expression. In the second expression, we divide a floating point value by an integer value. And if we do that, the result will be also floating point value. And I noticed I forgot to add a semicolon here. Okay. So we have these rules, but these rules don't include remainder here. So we'll talk about some special case for remainder. So there are some special situations that we need to know when we use division and remainder operators. So for the division operator like this, the first example, if both operands are integer, so if we divide one integer by another integer, like the first line we saw it here, the division operator will drop the fractional part. So what is the meaning of fractional part? So the meaning of fractional part is that the value we have after decimal point. So that is why in this case, in the first line, if we divide 1 by 2, the result for C is not 0.5, although we know the result is 0.5. However, because the two operand 1 and 2 here are integer value, so when both operands are integer, the division operator will just drop the fractional part. So that is why it will drop 0.5, it will drop the dot 5, this part. So the result will be 0 for the first line. And for the second, for the remainder operator, the remainder operator have a limitation here, or have a special rules here. That is, if we want to use remainder operator, we can only use it with integer operand. So we cannot write the expression like this. So we cannot use floating point number in the expressions with using remainder operator. So if we write down something like this is wrong, you will get the compilation error. Okay, let me add to the semicolon back. So if you solve any expression, and in that expressions, the expression use floating point value or floating point variable with remainder operator, then you should know that this program will not pass compiler, because you will get a compilation error. And the other thing we need to pay attention to is that if we use 0 as right operand for division and remainder, then it will cause undefined behaviors. So the reason is pretty simple here. I believe you also learned it in the math class. That is, if we put 0 as the right operand, that is the operand here, that means that we divide something by 0. Then if we divide any value by 0, the outcome will be the infinite number, right? And that is too much for C. So if we do that in our C code, you will get undefined behaviors. And we will talk more about undefined behavior in the later slide. But now what you should know is that we should avoid any chance that our program can generate something that is undefined behaviors. So we should avoid it. So please don't write something like this in your code. And the other case is that what if we mix positive value and negative value together in the same expression? So C also have different rules when it encounter this situation. So the first thing is that if one of the operands are negative, is negative. For example, in this case, only one operand is negative number, right? So in this case, if we use divisions, then what the division will do is always truncate toward 0. So truncate toward 0 means that it will drop the fractional part, but it will try to make this return value closer to 0 value. So that is why you can see if the return value is look like this, and it will just drop the fractional part, drop the part after the decimal points to make it closer to the 0 value. So that is why the result of these two expressions are both -1, because the fractional part will be dropped. So if this situation happens in the expression where we use remainder operator, then what happens is that the returned value, the result of this expression, will have the same sign as I. So I represents the left operand of the expression. So that is why we can see the example here. If the value of the left operand is minus, then the result of this expression will be -2. And if we have this case, the minus symbol is at the right operand, then the return value is 2, because the return value will have the same sign as the left operand. And in the second line, the left operand is 9. It is not negative value, so that is why the result value is also positive value. And finally, in this case, we have both operands have the minus sign, right? But again, we just apply the same rules. The return value, the result will have the same sign as the left operand. So in this case, the result is also -2 for the third line. Okay, so we after introduced all the arithmetic operator and some special case here, then let's talk about how to interpret a more complicated expression. So how can we understand the meaning of the expressions with more than one operator? For example, we have the expression like this, right? And we can we can understand this expression in two ways. So the first way is that I just start to read this expression from left to right. So if I do that, I might say that, okay, well, this expression want to do is to add I and j, add it together, and then multiply the result by k. So this is the first version of the expression. But we can also have another interpretation. That is, I think that here, I think is the meaning of this expression is that I need to multiply j and k first, and then add the result of these multiplications to I. Then we have two options here, right? But there's only one correct answer here. So if we encounter this case, which one is the correct meaning of this expression, and how can we know that? So, before I introduce the precedence and associativity, I want to introduce the best solution for this problems. So if you write some expression like this, and you want to make sure that the thing you want this expression to calculate is the same as in your brain, then what you need to do is to add as much parentheses as you need. So the parenthesis is 小括号 here, the parenthesis. For example, if we want this expression to do the meaning, the first meaning we explained here, we can add the parenthesis to tell our computer that this expression should be calculated first and then do this expression. So if we add the parenthesis here, our computer will add A, I, and J first and multiply the results by K. And in the other meaning here, if I want my expression to do exactly as we describe here, that is multiply J and K and then add the result to I, then we should put the parenthesis around J and K. So in this case, your computer will definitely run the expression. We put it inside the parenthesis first and then calculate the expression that is outside the parenthesis. So parenthesis is an important tool because it can directly tell what kind of things your computer needs to do. So that is the first solutions, and we'll talk more about the importance of adding parentheses in the later slide. However, before that, I want to introduce why we need to understand precedence and associativity of operator. So let's imagine that in one case you encounter an arithmetic expression. However, whenever who created this expression, the person forgot to add parentheses. So in that case, you still need to understand the meaning of the code, right? So if we don't have any parentheses in our expressions, then how can we know how C interpreted this expression? So actually, C will use operator precedence rules to determine the meaning of the expression. So first, I want to introduce what is operator precedence rule here. And if you understand the operator precedence rule, it can help you to understand others' code better. So for the arithmetic operator, they have the following relative precedence. So the highest precedence is here. This is the mid-level precedence here, and here is the lowest precedence. So if we have a high precedence, that means that we should evaluate, we should calculate those operators first. So let's check out this case here. So actually, you don't really need to remember. I think it is easy to remember because we need to calculate the multiplication and division and remainder before the addition and subtraction, right? And actually, this rule is the same as the rule we learned in the elementary arithmetics, right? We always say that we need to 先乘除后加减. So that is also true when you use C to do this arithmetic calculation. And in here, the operator that have the highest precedence are the unary operator. So we need to determine whether this value is positive value or this value is negative value first, right? So that is why the unary operator have the highest precedence in the arithmetic operator. So after knowing this, you should be able to add the parentheses by yourself, and you should be able to know which part of this expression will be calculated first. So in this case, it is the case we saw in the previous slide, right? So in this case, we know that we need to do the multiplication and division operator have higher precedence than the addition and subtraction, right? So that is why we need to in this case, J multiply K, this part will be calculated first. And then we will add the result of this part to I. So this expression is equivalent to this expression here. So we use the parenthesis to show you which part in this expression will be calculated first. Again, you can apply the same precedence rules in the following two lines. So I will give you guys some time to read about it. So please try to remember these rules and try to think about why these two expressions is equal to these two expressions here. Okay, I believe most of you can understand this, right? So, okay, I'll just quickly explain this because I believe over like 80% of you already know this part. So in this case, because we have two unary operator here, right? So that is why we need to apply the unary minus to I and j first. So we put the parenthesis here, and then we do the multiplication to these two parts. And in this case, we have another unary operator here. So so the positive operator will apply to j first. And then we have another set of division here. So this division will be calculated first as well. And then the return of these two, I would say sub-expression, these two expressions will be added together using this addition operator. So this is the simple one. But what if I have the expression contain two or more operators with equal precedence? What if all these precedents are the same? We have these two, for example, we have these two expressions here. So how can I know which part I should calculate first? So that is why we also need to know something about associativity. So the associativity can let us know that if we have this situation, which part of the expression will be calculated first. So there are two kinds of associativity, that is left associativity and right associativity. So if we say an operator has the left associativity, that means that we need to group this operator from the left to right. And all the binary arithmetics operator have left associative. So for example, in these two examples, they all have the left associativity. So that is why we need to put our parentheses look like this. We need to calculate the left expression first and then start from left to right. So that is why the parentheses should put like this. So I minus j will be calculated first, and then we will calculate the results of this expression with the subtractions and k. And this is the same for the second line here. We will multiply I with j first, and then we will divide the return value by j next. So that is how we can interpret these two lines. And we also have another operator that is left associative. So if an operator is left associative, we need to group them from the right associative. So if we have the right associative, we need to group them from right to left. And all the unary arithmetics operator have the right associative. So if you saw something like this, this expression is equivalent to this expression like here. So we group the operator from the right to left. So that is why we can put the parentheses like this. Okay, so after showing all these operators, I know I introduced a bunch of things. So this slide, I just want to check if you guys understand what I introduced in the previous slide. So here, I want you to think about the precedence and the meaning of different operator here. So you need to know which part of this expression that we use with the y will be calculated first. And then we will wait until we have 30 submissions. I hope we can get a correct rate. That is about 80%. That's okay, we can check out the results. Oh, no. okay. Don't worry. That means that we just need to explain this quiz properly. So around like 60% of students choose the correct answer here. So I will just quickly explain why the result is 7 here. So, okay, let me try to write it down. X 2. I'm not sure if the people sit at the back can see what I wrote on the blackboard. It is okay. If it is not okay, I will use the computer to explain it. Please let me know if it is okay. Give me a circle. It's okay? Thanks. Thank you guys. Okay. So let's start with it. So the number, the value we assign to x is 5. So what we need to calculate first is that we need to calculate this part first, right? So we need to 5 plus. So our goal is to understand the return value of all these things. And like I said, the arithmetic operator, this binary arithmetic operator are left associated. So we need to calculate from the left to right. So 5 multiplied 2 is 10, right? And 10 divided by 4 will be 2, right? And then we need to calculate the result of 2 remainder. What is the remainder if we divide 2 by 3? Yeah, that is 2. So that is why the result is 7. So I believe most of you will have the problems. Maybe the most common error will happen in this part. So yeah, so we can think about the remainder if we divide 2 by 3. Because 2 is smaller than 3, so the result will be 2 itself. So 5 add 2 will be 7. So that is why the result of this quiz is 7. And if you want to learn more, I encourage you to type this quiz on your computer and try to see what is the output of this code. Okay, thank you guys, and let's take some break. So please come back here after 5 minutes.